do chapter 8, 9 tests. First one here is, see, side with angles on either side. So it's angle, side, angle. And so we will do maybe law of sines, but then I'd have to know why, but that's pretty easy. If we know two angles, the third one will be 180 minus those two. So 87. So doing, see, if I want to find x, that's a side over the angle opposite is sine of 78 degrees equals any other side 7 over the angle opposite sine of it. So 7 divided by sine 87 times sine of 78 and 6.856. Okay, number 2. Well, this one we have two sides and an angle not between the two sides. So this is angle side side. So we've got to go for two options here. Okay, let's see. Can we do law of sines? Those are across from each other. So yes, so I'm looking for an angle. So sine of x over the side opposite equals the sine of any other angle over the side opposite. And that would make it sine 34 divided by 140 times 213. And then I got to take the inverse sine of both sides of that answer. And I get x could be 58 degrees. And if it was 58 degrees, then to find y, it's 58.29. I probably should write that, 0.29. Actually 0.3 if I round properly. So 58.3 degrees plus 34 degrees. Okay, and then take that from 180. And this one would be 87.7. Don't need that, but it helps to find y. So that'd be across from it. So y would be, then, if this is that angle, then y would be doing y over the sine of the angle opposite, 87.7, equals any other side. Let's see. Let's use the one we have here, 140, over the angle that we know for sure, sine of 34. So I do 140 divided by sine of 34 times sine of 87.7. And I get the side y would have to be 250.16 if you want. Close enough. However, since it's angle side side, you would become one of these if you do not go for a possible second one. Now, if this is 34 and 213, 140 could lay this way, or the 140 could be sitting inside here. And that 58.3 we found could be this angle. And the actual angle in this other possible triangle, this one, would be here, which is 180 minus the 58.3, which is 121.7. So x could also be 121.7. And if it was, then y would be this much shorter side, y over the side angle opposite. This would no longer be 87. It'd be 121 and plus 34. And 180 minus that answer, this would be 24 up here now, 24.3. So y over the sine of 24.3, y over the side opposite equals any other one, so 34, and opposite is 140. So this looks the same, this looks the same, except now we got a different angle here. And so the new y for this possibility would be 140 divided by sine 34 times sine of 24.3. And that would be 103.03 if I carried it out that far. Okay. Number 3. Looks like we know side, side, side on this. Now, the only important thing on side, side, side is to remember that in the formula where the angle, in this case x, is equal to the cosine inverse of a side squared plus a side squared, and these have to be the adjacent sides, and the one that's subtracted has to be the opposite side, 52 squared, over 2 times the two adjacent sides to the angle we're looking for. Now, some people set this up properly like this, but then when they did the calculation on this, cosine inverse, they didn't group their numerator or they didn't group their denominator. Numerator is 78 squared plus 90 squared minus 152 squared. Close the numerator, divided by, and you got to group these together, parenthesis, 2 times 78 times 90, close parenthesis, and then close all the parentheses for the cosine inverse. And I got a domain error because I didn't do something right. Let's see if I can figure out what that is. 2 cosine inverse of adjacent side 78 squared 90 squared minus 152 squared. Oh, there it is, 78. Second insert of 70. I didn't do 78 times 90. Okay, now we should get something. And it says the angle x is 129.44. And that's that angle. Doesn't look like 129, but 152 is a lot longer than either of these. So this should have been a lot longer side. This would have been a big angle. So when I'm trying to find the area of this, the area is 1/2 a side sine of an angle that's between the two sides. And we now know the angle between these two sides, so we have to do 1/2 78 times 90 times the sine of 129.44. So I'll go 0.5 times 78 times 90 to get the 78. Yep. Sine of that last answer. And I get 2711. Areas in square units. Okay, page 2. Find the length of AD. Well, we know one side and one angle of this triangle, and it's not a right triangle, so we can't use SOHCAHTOA or anything like that. But we got some stuff up on this upper triangle that we might be able to find this side. This side and across from that angle, and this angle is across from this side. We can use the law of sines to get x if I knew that angle. But these two together, that would be 70 from 180, which is 110. So x over the sine of the angle across from it equals any other side over the sine of the angle across from it. And we get x to be 8 divided by sine 25 times sine of 110. And we get x to be 17.79. And now we have side, angle, side. We should be able to get that one using the law of cosines. This one that we want to know, let's call it y. Y would be the square root of adjacent side squared plus adjacent side squared minus 2 times adjacent side cosine of the angle between those two adjacent sides. They're adjacent to this angle. So we have square root 11 squared is 121 plus 17.79 squared minus 2 times 11 times 17.79 cosine 68. And we get y is equal to 17.05. A surveyor sets up a point alongside a lake. So there's some point here, and the surveyor measures the distance from her to one end of the lake is, oh, let's say it's this one, 2.35 miles. Looks to the other end of the lake, and it's 4.71 miles. And the angle made by these two is 150 degrees, 37 minutes. Well, we got side, angle, side. We can find the opposite side. It's pretty much the same as what we just got done doing here. It'll be the square root of adjacent side plus adjacent side minus 2 times the adjacent side times the other adjacent side. And they're both adjacent to the angle, which is 150 degrees, 37 minutes. Minutes, 1 dash. So on my calculator, I type in the square root 4.71 squared plus 2.35 squared minus 2 times 4.71 times 2.35 cosine 150 plus 37/60 more. And that would finish it. And that means the lake is 6.85586 miles long. Okay. A plane is flying 135 miles an hour at a heading 32 degrees west of south. So if I were to be headed south, I have to go west of south. So I have to think south, turn 32 degrees towards the west. 135 miles per hour. So I can either figure out this angle, which would be 270 minus 32, or I can use this angle, which is negative 90 minus 32 more. I'll do this one, so that'd be 135 miles per hour at a heading of 270 minus 32. 270 minus 32, 238. And then the wind is 45 miles per hour. That's how big it is, in an easterly direction. So it's blowing to the east. That's at 0 degrees. 45 miles per hour to the east. East is 0 degrees in trig. Oops, I should have pushed that up a little bit there. So now, let's figure this out. So we got to do 135 cosine 238, negative 71.54, and then the same thing with a sine, negative 114.49. And this 45 is all in the x direction and none in the y direction. You can do 45 cosine is 0 and 45 sine is 0, and you come up with those. Add these. So this will be negative 114.49. Plus 45 to the first one, and it's negative 26.54. So to change it back and get the actual speed, I have to go x squared plus y squared is the r squared. And so I got to take the square root. So it's the square root of 26.54 squared. I ignored the minus because I'm squaring it. I'm going to square that one, so I don't need the minus in there. Plus 114.49 squared, square root. And I get the speed is 117.5 miles per hour. And the heading in trig would be, since the x is negative, I'm going to have to add 180 to the tangent inverse of y. And these are both negative, so I'm going to forget that. Negative divided by negative is positive. 114.49 divided by 26.54. And then plus 180 and that's at an angle and trig of 257 degrees approximately. So 257 is almost here. It's also some amount west of south. So it's 117.5 miles per hour at an angle, let's see, 270 minus, that would be 13 degrees to the west of directly south. This could also be said south 13 degrees to the west. That's the other way to write that. And the last page, convert this to rectangular. So you do 7 squared plus 5 squared. That's 49 plus 25 is 49 plus 25 is 74. And tangent inverse of 5/7. So we got the square root of 7 squared plus 5 squared, which is, if you want it in decimal, 8.6, comma, and you want to write it in terms of x, comma, y. And the y coordinate is, and we don't have to add 180 because the x is positive, so tangent inverse of 5 divided by 7, which is 35.54 degrees. B, x is our cosine theta equals 0.4. Y is squared. Now y is our sine theta. If we're going to square it, the r has to be squared and the sine theta squared, or you can put parentheses around all of it and square it. X plus y equals 2. That's those two. Now if you're converting back to find the, this is r theta, excuse me, up here, r theta. Down here we're finding xy, and that's r cosine theta minus 23 cosine of 20 is minus 21.61 in the x direction. And with the sine, we get the y direction, negative 7.87. R cosine theta, R sine theta. All right. The only thing a little tricky here is we want to make, it's easier to do R cosine theta, but there's no R here. But if I multiply this side by R and this side by R, I have negative 7R R cosine theta, which is x. So I got negative 7x on this side. Over here I've got r squared. Well, r is the square root of x squared plus y squared, so r squared is just x squared plus y squared. This one looks like it goes from 0 to on the circle to out to about 4 out to back on the circle, back. So it looks like we're talking about a circle of radius 2 plus 2 more, but we're starting on the circle. So the amplitude of 2, so we can go 2 more and then 2 less. Here we're inside. And the what starts on the center line is the sine. And we have 2 loops, so it's probably 2 theta is what r equals. And now a lot of people left the r off, and I didn't dock you on this, but if I was a test, I would the retest, I will. Now we need to make this be in radians to make this graph correctly. And so we go to y equals, r equals mode, polar. Now we can go here. 2 plus 2 sine 2 theta, and graph. And it looks correct. Determine the length of this, the norm of this. That is just 2 squared plus a negative 7 squared square root. So it would be 4 square root of 4 plus 49, which is square root of 53. You can get decimal for it if you want. And then to make this vector that's this long, only 1 unit long, I have to divide the length of this by 53. So I got to take 2 divided by the square root of 53 in the I direction, minus, because that's a minus there, 7 over square root of 53 in the J direction. And finally, if this is U and this is V, and it says in that order, respectively, in that order, U, V, do 2 V's. V looks like this, so if I go a V, that should look like that one, should be parallel to it. And then another one that looks about the same length and parallel to this. So these should be parallel to this. And see how they fit right down the side of my pen. Match up. And then we got to go minus 3u. So this is a plus u, so minus u goes just in the opposite direction. From where I left off, I got to go parallel to this. So I got to go at the same direction over here. So it wants to go in this direction and about the same length, but that direction. 2, 3. That should look about the same direction as this, same parallel. These should look parallel. Okay, and then my answer for this is from where I started to where I ended. And that's that test.